For kids in Williamstown, late October and early November are centered around Halloween, with the fear of ghosts and ghouls occupying their nights. As for students, we fear trips to the library and the never-ending cycle of midterms. But for our Hopkins Memorial Forest caretaker Drew, various students from Williams College and MCLA, and some local community members, these autumn nights are filled with the task of owling. For the past 20 years, the Williamstown area community has spent over 3,000 hours capturing and banding Northern Saw-Whet Owls for an international study tracking their movements and behavior. Now, we will journey into a night at our banding station. The first step is to capture our owls. We have three 12 by 2.6 meter mist nets which are hung between poles along a path in the forest. These nets are delicate, thin, and very hard to spot in the dark. In order to prevent damage, we only unfurl them at dusk right before the owls start moving, and we frequently remove all the twigs and leaves. The nets are outfitted with a motion-activated sensor. It flashes a light when there is movement on the net so we can get to the owls immediately when caught. We also do a full check of the nets every half hour. Throughout the evening, we project a continuous broadcast of Northern Saw-Whet Owl calls to lure passing owls to the nets. If we get lucky, we might intercept some birds. When capturing owls, safety and comfort for both the handler and the owl is prioritized. Saw-whet owls are small and are at risk of predation from larger barn owls while caught in the net. Recent years have seen an uptick in predation, so we have instituted a series of protocols such as more frequent net checks, near consistent net monitoring, and a smaller netting area. We are also experimenting with infrared illumination and night vision goggles to scope out potential predators and keep the saw-whets safe. We can't predict exactly when the owls will come, so some nights are spent waiting and trudging down to the nets on the half hour without any sightings. On other nights, we are constantly running back and forth between the nets and the banding station with owls. When we find an owl in the nets, an experienced handler will gently untangle them and place them in a breathable cloth bag. The bags are for the owls and the handler's safety during transportation. They also help acclimate the owl's eyes between the illuminated research shed and the dark woods. The first information we gather is environmental data. This helps us predict in the future years what conditions bring out the most owls. We note the moon phase every night, and every hour we record meteorological data such as temperature, precipitation, wind direction and speed, and percent of cloud cover. When we capture an owl, we pay attention to several details at the site. We note the time of capture, location on the net the bird got caught in, direction of entrance into the net, and any notable irregularities. Once we take the owl back to the shed, we first band the owl just in case it escapes. The bands are little bracelets with a unique number. They're federally issued and used for identification. If we capture a banded owl, we can know exactly when and where other researchers have caught the same bird, which helps with studying migration patterns. Next, we need to weigh the birds. This is tricky because the owls tend to move around on the scale, giving us irregular mass measurements. A common technique used by ornithologists is to stick the bird's head first into a can to keep them still. The snug and dark space calms down the owl and it doesn't hurt them at all. Weight is an important measure of health and fitness because it correlates to the richness of diet and how far a bird can travel while migrating. Next, we measure different lengths on the owl. There are two kinds of measurements we take for the wing. The first is the wing chord, which is the length of the primary flight feather's natural arc. This is a standard ornithology measurement, and it provides a good index of bird size. The second wing measurement is taken while gently pressing the wings flat. This method isn't common nowadays, but it is useful to compare this data to earlier measurements that were done this way. To find the tail feather length, we measure the central rectrix feather. This is also used as a proxy for size. Lastly, we take the bill length with calipers, measuring from nostril to the beak tip. The first qualitative measurement is the eye color, which we determine with a customized eye color chart. This is a feature that is scored uniquely in saw-whets, and we're interested to find correlations between eye color and age, sex, nutrition, or other factors. Second, we determine fat accumulation with a qualitative score ranging from 0 to 3. This, in addition to mass, is helpful because it shows how much of the weight is stored fat, which again is tangible evidence of stored energy available during migration, surviving lean winter periods, etc. It is difficult to tell the sex of an owl at a glance. They display reverse sexual size dimorphism, and in about 85% of cases, females will be larger than males. With a discriminant function analysis between mass and wing chord measurements, we can make educated guesses of the owl's sex. When an owl falls within the gray zone in between the two, we mark it as unknown. In order to determine age, we open the owl's wings and place them under ultraviolet light. Depending on how old they are, the feathers fluoresce different colors. We infer age by the number of generations of feathers appearing on a bird. For example, a bird exhibiting all uniformly new, clean feathers can be assumed to be a hatch year, while one with distinct blocks of feathers exhibiting 2 different degrees of wear can be assumed to be a second year, and so on. After about 3 years, all of the original feathers would have been replaced, so determining the age of an older bird is very difficult. However, only a small portion of saw-whet owls in the wild make it that far. The short answer is we're just getting to the point where we're learning things. Studies like this take a long time to come to fruition because we need a lot of information, and our data collection period each year is very limited. Combining all of our measurements with demographic and geographic information may allow us to separate subpopulations, determine climate change effects, and characterize behavior differences between sexes. Next fall, feel free to come meet our team and the adorable saw-whet owls.